Hey, welcome back to the StackIt series. Um, Last time we finished implementing Monte Carlo tree search, and today I want to let Monte Carlo and Alpha Beta play against each other, and we can take a look at this. A couple of things that I did in between the videos. I was curious how Monte Carlo would fare against Alpha Beta from our starting position from the game that I initially lost. Maybe you remember it was episode 12 or something here. And I think Alpha Beta chose to play here, and then the response would have been to top over instead of like play here or something else. If we run this position with Monte Carlo tree search, giving it 10 minutes and basically playing 100,000 moves, which probably always leads to an end game, it runs about 200,000 games, and we can see that it favors the position 1-0 with about 52% win rate. And then the improvement of actually choosing more promising moves more often. We played this 125,000 times versus only 3,000 times the worst move. And then it's 3-3, and then 2-0, the move that Alpha Beta would have taken, is on third place. And then immediately Alpha Beta ran against this, and this is not so important. One thing I actually wanted to compare it to is now I ran the same position again, but I disabled the improvement of playing more promising moves more often. So you can see roughly we played them all the same times, but still 1-0 is the most promising move, and 2-0 is on third spot. So I think this is actually a good improvement. I wanted to see if it will maybe change its mind and play this move, for example. Anyway, well, this is one thing. Let me just see if there's any other diff. This is the diff to the main game that I made. Yo. Yeah, here I switched the order of some print statements. I need to add this improvement. So I didn't commit this yet, so let's not do this and not do this. But we want to add this, and we want to add this, and we want to add this, not this. Commit. This was episode 14, I believe. Wait. Oops. Git log. Oh no. It was 14 indeed. 15. 14 was the last episode. Can I just empty amend something? Okay. Are we really episode 16 right now? Well. Improve Monte Carlo tree search. This contains the improvement. Okay. Good. This episode we will refactor our main game loop a little bit, maybe improve the playability of this, and then yeah, we will actually duke out the two AIs against each other. So currently the way it works is super simple. There's an exit command, there's a AI command, perfed, and then if none of those was chosen, we default to play. I want to change this up a little bit. Please input a move. Maybe this is okay, but I definitely want to keep track of who's a player. So players will be a dictionary of player 1 goes to human, and player 2 goes to alpha, beta, maybe. Something like this, or should we actually put an object there? Maybe. We can actually instantiate this class here. So we'll print the board, then we can enter some command. I will bring this back later. Perfect. I'm not sure. Yeah, let's leave this for now. I will actually call this search. And then, okay, if we get here, do I want to keep this? Perf never finishes, I guess. Here we're gonna have a new command as well, and then we can say that why not board winning player? Actually, this will be a while true loop. Okay, new board, actually run game, doesn't need a board. Here we do empty board, board equals board. And maybe we'll be able to pass something here, but now we can actually at least reset. Then we go here. Yeah, I like this much more. And then we can, this is more or less for debugging from string, board string. I want to refactor this board string as well. Search would just call call alpha beta on the board. I don't think we need this. What is this doing right now? It's printing some performance test, but I think we just want this. Maybe I move this into the function again later. Search. For now we use alpha beta because it has nicer something like this. We don't use this move. And if else. So then we assume we are actually playing. If players board current player equals human, then we will treat this as human input, where we move split, I don't know, space or comma better, board move can actually be split move, okay. Else, then we know it's an AI player, and here we can just do, how did that happen? We can just do players board, current player, get build move from time, board, thinking time, performance test true. For now we leave this, okay. Okay, and then move equals set. Okay, sorry, the video got interrupted here. We were about to actually add a couple of methods to our main game loop. One of them is actually, let's change this, starts with, oops, set. So if our move, which actually we're gonna rename to command. If our command starts with set, we split it into the command, the player, and the type. We can do something like this because I'm for sure gonna forget this. If it's only set, print usage set player number, and then player type. I think there's probably a library which would help me set this up a little bit. Oops. Better anyway. Type H A M. Let's keep it lowercase. And then let's see, we print the board here, we print the command, and else we assume it's this, and then we said player, and this one should be int, oops, player equals yeah, and then if player type I should put this into a constant. There's an F string, something like this, and then this is also not the best place to have it, but whatever, we have our constants up here, and then we can for now I don't want to parameterize my AIs, so okay, we have if player is human, elif player type equals alpha, and then alpha beta, something like this. So now we can set players. We should actually also print players. Okay, we print the board here. We will print for P player T in player type, not in player type, in players items, print and this one will be P, and this one will be T. Something like this. Then we print the board. Then let's just see. We do a move. After moving, actually we should probably print the board. But now I'm going to move this inside. Maybe I went down a rabbit hole. Okay, let's do it like this. We print the players, we print the board. We can do this now. Let's just say, see. Okay, player 1 human, player 2 alpha beta. This is something we should make nicer. Later, it's fine. Now we can do a set 1 MCTS. And now it is indeed a Monte Carlo tree search. Cool. Now, if I just press enter, it will go for it. And where did I say the thinking time is 600? That's ridiculous. Let's make it 10 seconds. So, oh god, I already see what I'm doing. This is also not good. I'm just thinking, somehow we want to have a flow which makes sense here. So first the game starts, which is good. We enter a command. Or actually move. We should put this in here, right? For now we need to figure out how to, this will, okay. Set 1 MCTS, does this work? Nope, because we now expect it to be a move. Let me just think real quick what makes sense. So if we demand input here, we would always be asked for input, even if it is not our turn. What if we yeah. Let me just think real quick. So, okay, it's kind of late here too. I'm a little bit tired now. We ask for this. We should have separate command and game loops. As soon as we start a game. But I want to be able, for example, to say search. The problem now is we always have to press enter. What we could do is something like this. search. This should also be thinking time. Also Z1 MCTS. Let's see. Oh yeah. Oh. What happened here? Oh yeah, now they don't make a move. Oh yeah. And this one will give me move, score. That will be a move. And forward move. Okay, and why don't you move? So it goes in here. Command is empty. Should go here. Oh god, I'm sorry. This video is gonna be super boring, but maybe I mean, one question is if we have two AIs playing, how should we get out of it? I already thought a little bit about it and thought that I could capture a keyboard interrupt to get out of it. Let's just see what happens here. So yeah, I'm done. I'm so funny. Okay. Now the command will never be overridden. Yeah, this is not nice. I mean, it got a little bit cleaner, I think, but what is messy now is the control flow, right? Like, okay, if we enter something here, then maybe we're somehow there, but somehow we're also looping around. And I bet whatever I'm changing in the future, it will break all the rest. So, oh, is this score move? Is this score move? Or does this just return a move? Oh, yeah. Score. And alpha beta returns best move, best score. Best move, best score. They definitely return both move, score now. Move, score. Oops. And then I also wanted to let's see, what did it say? It thinks 1 0 is good. 1 0 is good. It always thinks this. And you think 0 0 is your best bet. Is it? Okay, cool. Now we can actually also interrupt this. Press new. Oh, this is also something I want to do. Because if I now I can let it run a little bit, but this won't be very helpful. So I want to have starts with new if command equals new. We just do this. Size x size 1. don't really have a good constructor for this, I think. Size x equals size. Wow, do you hear how my laptop is fanning along? I will kill this. Let's just see how this worked out. Wow. Flying away. I'm sorry for the audio. This really screws up the audio. Okay, we started from an empty board. We managed to do 800 full games in 10 seconds. And we found that 4-4 seems to be a good point. 4-4. Apparently we won 60% of the games playing on 4-4. Yeah, this is how I programmed it. I told it the middle is better. And then 4-4, still the winner. Play somewhere else. Oh no, let's see how this will work out. Okay, I just want to make it so that I can 0 for, let's go in range size x for, and let's go in range size y. Okay, and then this one is the inner array, this one is the outer array. I think, and then did I use some range? Okay, cool. Now I can initialize my board with sizes. So now I can do new 3-3-3-3. Bomb. Oh yeah. Okay. New 3-3. No one. User interfaces are always clunky. I don't know. And I shouldn't probably do this. Okay, 3-3, nice. Third one in CPS, let's see. I will just let this run for a little bit. This is so funny. I think they should all be roughly equal. I don't know why this particular field should be any better than this, since it's symmetric. So 2-1 and 0-2 should have the same probability of winning. Funny though that this algorithm likes this one too. I mean, now after the first player, maybe. 4, you just take another one, you play here. Yeah, it seems that oh, sorry. Let's just follow the main line. Oh. Okay, let's see. It seems to be losing soon. Why did you do this? Why did you not do this? Alpha beta thinks it's losing in depth 12. And here it was losing in depth 10. So cannot move on top of another player. How? 1-0. I should update my board. Class cannot move on top of another player. Current player equals current player. And x equals x, y equals y. Something like this. Okay, it's maybe not nice that this new 3 set 1 entities. Let's see if they come up with a similar move order. Oh no, really? Oh god. Oh no. New 3 set 1 entities. Is on top a single word or 2 words? Spelling, typo, change to. Now suddenly, like, I guess the branching factor is really high because this is a huge variance in what's good moves. Now 2, now. Okay, cool. And I forgot a bracket closing. Ugly. Okay, let's figure this out and then we're gonna call it a day. So player 2 is good. Wanted to move on 2, y1. How is this on top of another player? Self. Current player. Self player y, x, y, x. Correct? Okay. 3, 3. Maybe we have a bug, which would be interesting. Can it be that we don't properly copy this? But then this print should look very different. StackIt cannot. Field says 1 on 2, 2, 1. 2, 1. It's somewhere in alpha beta. Oh. So it finds some hash move which is illegal. Let's go here, while true, get PV. Oh, Interesting. Pause board. If not hash move in board possible moves, I think. Break. Then we just have a broken PV. It's funny that this happens though. And that it happens. I should debug this. This is not a good sign. Okay, I will let it run one last time. Then we finish this episode. It's already getting long. And I apologize for the second half a bit. It's quite late here now and I feel tired, and probably if I could have finished this earlier when I started the first part of the recording, it would have been a little bit more interesting and I would have talked a little bit more. So suddenly this move is so much better than the others. I mean, okay, 10 seconds is not a lot, but it's still 7,000 games. It's probably also not a lot. There's so many things I want to do with this. It's quite exciting, but changing the board to a NumPy-based class will probably speed these up quite a bit as well. Maybe before we start this, we want to do some profiling because, you know, premature optimization. Oh. Monte Carlo thinks it's winning and Alpha Beta thinks it's winning. Oh. Alpha Beta found that it is winning. Let's see if this holds true. It will just take 8 moves. Oh, now Monte Carlo sees it too. Ooh. Too late. He still thinks you're winning 50% of the time, and here... Which is funny, maybe something we should debug. Oh yeah, well. Okay, there's a couple of bugs that came out. I guess here it would be interesting to also print the principal variation that Monte Carlo sees here, which is like how far did we expand this tree, because the pattern of 2, 0 and 0, 1 should have shown up. Because we can also just try to give it more time, and then we should figure out what happens with the move here. So see you next time.